there's an elevator just up there, and I think you always take that door down.
Gamma rays are the highest energy form of light. They're only produced by incredibly energetic events. If they were oriented the right way, could be dangerous. Really, the big danger, if they were really close, would be killing the phytoplankton in the oceans, which is the basis of the food chain and would work its way up, so you'd be talking about a mass extinction event. It would be incredibly rare because it has to be close by and oriented just enough, and only the most massive stars go off that way. Most of the stars in the universe are much smaller, so they don't go off in gamma ray bursts, and they last much longer. The things we study are gamma ray bursts and other high energy phenomena. I was brought in about 4 years in. Even though I've been here now 14 years, I'm still kind of the new guy. The mission was built to solve one of the big mysteries of the 90s, which was what were gamma ray bursts. Right. There were these flashes of gamma rays that would occur around the sky, and by the time we got a telescope on it or knew it was there, we wouldn't see anything. Whatever it was that had created that flash of gamma rays had disappeared. My tasks with the telescope are I'm instrument lead for the UV optical telescope, so I manage its health and safety and calibration. And we have a team of people here and in the UK that help me with that. And I also, once every 10 weeks, am what we call observatory duty scientist. That's where I'm on call for the spacecraft. So when people send in requests for observations, we get over 1,000 requests for observations every year. I handle those. And when we have a gamma ray burst or some other event, then I handle that, decide how we're going to observe it. I would say in my early days, sort of, there's a steep learning curve with figuring these things out. But once you get into it and understand sort of the priorities of the science team and which bursts are interesting, what targets are most important, you sort of develop a rhythm with it. It is something that I do every 10 weeks, and that's sort of, if you do longer, you sort of tend to get rusty because there's a lot to know, a lot of skills to have, a lot of programs to remember. But you really do develop an ease with it. They were actually detected first in the 1960s by spacecraft we'd put up to detect nuclear tests because nuclear bombs give off gamma rays. And so we had them in space to see if the Soviet Union was in compliance with the test ban treaty that we'd signed at the time. But they started detecting flashes of gamma rays from space. And it can only be something extremely energetic. Swift can get on them usually within a couple of minutes. Sometimes we've gotten as short as like under a minute. So seeing those, what you have is you have this initial explosion, and then you have this X-ray afterglow of all this hot gas blowing out from the explosion, and we study that to learn more about the internal engine. The bird, the Swift, which is our logo, it's a name for how quickly the spacecraft moves. Mm-hmm. And so what the spacecraft is designed to do is to slew very swiftly across the sky in response either to automated triggers or triggers we put on board. Because they happen on a very short time scale, you have to move the telescope quickly in order to get to them before you lose the information. You needed a spacecraft that could communicate rapidly to the ground, and then telescopes on the ground or in space could go rapidly to that target and see what was there. What Swift does is it has a gamma ray detector that scans about a sixth of the sky at any one time, and it's looking for these flashes of gamma rays. And if it detects them, then it automatically retasks itself, figures out how to get to that, and points our smaller X-ray and ultraviolet optical telescopes on it so we can get responses, and sends alerts down to the ground so that one can get online and look at the data coming down from the telescope, see what we detected, and other telescopes around the world trigger to that so that they can go on that part and look and see if they see anything as well. Usually we get 1 or 2 gamma ray bursts a week, but they're stochastic, so we can go weeks without one, and then we can have a whole bunch in a short time. And one night I was on call, it was early in the evening, gamma ray burst goes off. We deal with it, the science planner moves that into the program, then another gamma ray burst goes off. And then we respond to that, he works it into the plan, then another gamma ray burst goes off. And I emailed him saying, stop making plans, you're causing these to go off. And then we got a fourth one like around 3 in the morning or something like that. And so, I'm having to send commands to the spacecraft to observe all 4 of these because they all four were interesting. So I'm like juggling all these targets in the air, and the other ODSs are emailing saying, "Look, if you're getting tired, let us know. We'll help out." Because that's one of the great things about this place, that it's very much a team, and if if one person stumbles, the other people will pick them up. But that was a memorable night because we had 4 in one day, and all 4 were interesting. The first thing Swift detected actually was not a gamma ray burst. We just launched, and we still were not slewing. And what happened was we got a big flash of gamma rays, and it turned out to be a magnetar in the Magellanic Clouds. This is a pulsar, the shriveled remains of a star that has an intensely powerful magnetic field. And when it has a star quake, that lets out a huge burst of energy. And that was the first thing we detected, which we didn't expect to detect. Gamma ray bursts are probably, I want to say 10-20% of the science we do now, because people have figured out that having a spacecraft that can slew quickly and can get simultaneous X-ray and ultraviolet and optical data is incredibly useful. We do comets, we do active galaxies, we do exoplanets, a lot with supernovae. And so there's a lot of stuff we do that people have found for this capability. Mostly what we're doing is refining our understanding of them, and especially probing the early universe to see when these started.